Hello friends, now we have to solve this given differential equation. You can see here this is the given differential equation can be written as x squared d2y by dx2 plus 2x dy by dx minus 20y, this is equal to x plus 1 whole square. You can see here this is the second order homogeneous linear differential equation. This is the second order homogeneous linear differential equation. For solving the homogeneous linear differential equation, always we put x equal to e to the power z or z is equal to log x to the base e, or this can be written as ln x. And we put dt minus 1 y in place of x square d2y by dx2, and in place of x dy upon dx we put dy, where capital D this is equal to d by dz. Now when we solve the homogeneous linear differential equation, always we put x equal to e to the power z or z is equal to log x to the base e or ln x. And in place of x square d2y by dx2, always we put d minus 1y, and x in place of x dy by dx, always we put dy, where capital D this is equal to d by dz. So x square d2y by dx2, this can be written as d times d minus 1y, and in place of x dy by dx, this can be written as dy minus 20y, and in place of x we put here e to the power z plus 1 whole square. Now taking common y here, so we get d square minus d plus 2d minus 20 times y is equal to e to the power z plus 1 whole square. Now this 2d minus d, we get here d minus 20y, this is equal to e to the power 2z plus 1 plus 2 times e to the power z. You can see that the homogeneous linear differential equation is reduced into linear differential equation with constant coefficient. So you know that this is the second order linear differential equation with constant coefficients. So for solving this, first we write here auxiliary equation. So the auxiliary equation, for forming auxiliary equation, always we replace capital D by m. So we get m square plus m minus 20 equal to 0. This is the auxiliary equation. Now we find the roots of this auxiliary equation. You can see here the factor of this is m square plus 5m minus 4m minus 20, this is equal to 0. Taking common m here, we get m plus 5 minus 4 common here, m plus 5, this is equal to 0. So we taking here m, taking common m plus 5, we get m minus 4, this is equal to 0. So m is equal to 4 and minus 5. So the roots of the auxiliary equation are 4 and minus 5. Now we write the complementary function. You know that the complementary function can be written as c1 e to the power m1z plus c2 e to the power m2z. And m1 is here 4 and m2 is minus 5. So in place of m1 we put here 4. So we get here c1 e to the power 4z plus c2 times e to the power minus 5z. And this e to the power minus 5z can be written as e to the power 4z can be written as e to the power z whole power 4 plus c2 divided by e to the power z whole power 5. You know that here we put x equal to e to the power z. So we replace this e to the power z by x. So we get here c1 x to the power 4 plus c2 divided by x to the power 5. This is the complementary function. Now we find the particular integral on the right hand side. So particular integral can be written as 1 upon fd, and fd is here d square plus d minus 20, and right hand side is e to the power 2z plus 1 plus 2 times e to the power z. So we find the particular integral of each term. So first we write here 1 upon d square plus d minus 20 times e to the power 2z plus 1 upon d square plus d minus 20 times. In place of 1 we put here e to the power 0z, because e to the power 0z is 1, plus 1 upon d square plus d minus 20 times 2 e to the power z. Now we replace here, you know that the formula for particular integral of e to the power ax, this is equal to 1 upon fa e to the power ax, where fa can never be 0. This is the formula for finding the particular integral of e to the power ax. Always we replace small a in place of d and get the particular integral of e to the power ax. In place of a, you can see here, in place of a this is 2, in place of a there is 0, in place of a there is 1. So we replace here 2 in place of d. So this becomes 2 square plus 2 minus 20 and e to the power 2z plus 1 upon, here we put 0 plus 0 minus 20 and e to the power 0z. Here we replace, here coefficient of z is 1. So we replace 1 square plus 1 minus 20 times 2 e to the power z. So this is 4 plus 2 minus 20 and e to the power 2z, plus here this is minus 20 and e to the power 0z, plus this is 1 plus 1 2 minus 20, this is minus 18 2 times e to the power z. Now 4 plus 2 6 minus 20 minus 14, so this becomes minus 1 upon 14 times e to the power 2z minus 1 upon 20 and e to the power 0z, this is 1 and this is plus minus minus 2 9 18, so e to the power z divided by 9. So this is the particular integral. Now we replace this, so this can be written as minus 1 upon 14 e to the power z whole square minus 1 upon 20, and here we write e to the power z. Now we replace e to the power z from x and get the particular integral. So the particular integral is minus 1 upon 14 x square minus 1 upon 20 minus 1 upon 9 x. So the general solution is y is equal to complementary function plus particular integral, and the complementary function is c1 x to the power 4 plus c2 divided by x to the power 5, and the particular integral is minus x square divided by 14 minus 1 upon 20 minus x upon 9. So this is the general solution of the given homogeneous linear differential equation. Thank you.